Alright, here we have the guided notes for chapter 2.1, solving one-step equations. And again, the vocabulary is up to you. You are responsible for knowing what those words are, what they mean. And if you don't know the words at the end of this video, go and look them up in your book. They are in chapter 2.1 and the definitions are clearly written there for you. So if you don't know the words, go look them up. The golden rule of life. Well, the golden rule of life is to treat others the way you want to be treated. So there's some sense of equality here, right? I want to be treated just the same as the way I treat other people. The golden rule of algebra is that what you do to one side of an equation, you have to do to the other. Well, they really ought to know that we're recording here. We have some important recordings going on, people. So we have to keep equations balanced, right? In order for things to be said to be equal, if I add or subtract, or if I do anything to one side of an equation, and I don't do that to the other side, then it wouldn't be equal anymore. So that's the whole idea of making sure that everything stays equal. So here, using what and following the golden rule of algebra, we could solve one-step equations. Well, using the properties of equality. And the properties of equality can be broken down pretty simply. We have the addition and the subtraction properties, and we also have the multiplication and division. Now with addition and subtraction, there's almost no restriction. You can add and subtract any number you want. As long as you add and subtract the same number to both sides, it's okay. Now for multiplication and division, in order for us to save equality on both sides, the number that we use to add, multiply or divide must be non-zero. So that just eliminates 0 from all the real numbers ever. 0 is the only number that we cannot multiply and divide by to save equality here. So it asks us to solve each equation and state the property that was used. And here, the big goal, our goal, is to isolate the variable. That's what we want to have happen. Now, the variable in this equation, x plus 13 equals 27, is x. So we're trying to get x by itself, which is the idea of isolation, is to be by yourself. So we want to get x by itself. Now, we have to do the opposite of the operation that the number is being applied to. So here we have x plus 13. So instead of adding 13, I want to subtract 13 from both sides. And here on the left hand side, when I take 13 away, x plus 13 minus 13, now the 13's cancel out and I'm left with simply x. And on the right hand side, 27 minus 13 leaves me with 14. And we use the subtraction property of equality. On this problem here, my variable is b, so I'm going to try and get b by itself. Now, b, it says b minus 3, and I want to do the opposite of this, so I want to add 3 to both sides. And when I add 3, my negative 3, positive 3 goes away, and I have to add 3 to the left-hand side, so negative 7 plus 3 will give me negative 4, and that is the value of b. And for this problem here, I have x divided by 3 equals 2. Well, the opposite of division is multiplication, so I'm going to multiply by 3. multiply by 3. And now this 3 cancels with this 3, and I'm left with x equals, and 2 times 3 is 6. Alright, now x is my variable here, and I have 4 times x equals 64. So in order to get rid of the 4, I need to divide by 4 on both sides. So I'm going to divide both sides by 4, canceling that 4 there, and I'm left with x. Well, that's a terrible one. I can do better than that. X equals. And now 6.4 divided by 4 is 1.6. And that's my answer. We put boxes around our final answers here. Now, here I have a fraction. 4/5 times m equals 28. Now, essentially, we could divide by 4/5, which is okay. But instead of confusing it, I want to multiply by the multiplicative inverse. And the multiplicative inverse of 4/5 is 5/4. And I multiply both sides by 5/4. And that eliminates the 4's and the 5's. So my left-hand side I have m. And now I have 28 over 1 times 5/4. Now we can multiply across the top and across the bottom, but I know that 28 divided by 4 gives me 7, so I can really cancel that out there. And now I'm left with 7 times 5 to get me 35.